All right, now we don't want to have to go through a guess and check process every time we want to find an antiderivative. And so this table here in your lecture notes shows the antiderivatives for common functions, right? Like power functions, a constant. We already talked about 1 over x, e to the kx, where k is a constant. And then also the trig functions, right? We have sine and cosine, right? But I've shown it as cosine of kx and sine of kx, okay? Now the sine is interesting, right? Because notice you get a negative cosine. And, that's just because the the derivative of cosine is negative sine. So when you take the derivative of negative sine, you should get the cosine, right? That's what causes the antiderivative of sine to be a negative cosine, right? But essentially, if you know the derivative, then you could find the antiderivative. So this looks like a lot to memorize, but again, you're just you're just taking derivatives in reverse, okay? And then at the bottom here, we have the inverse trig functions, inverse tangent and inverse sine. Okay, because we know the derivative of inverse tangent, so that means the antiderivative of 1 over 1 plus x squared has to be the tangent, the inverse tangent. All right, so let's take a look at the next example. All right, so the first problem in this example is to find the antiderivative of the square root of x. So first thing I'm going to do is I'm going to rewrite this integral as x to the 1/2 power, right? Now notice I'm copying the whole integral and everything down again, right? I'm just changing the square root to a 1/2 power. But I haven't taken the antiderivative yet. So if you're just rewriting the integrand, you want to carry along, keep the integral and the dx, okay, to indicate that you have not found the antiderivative yet, okay? So make sure you do that. And then once we find the antiderivative, then we can drop the integral and the dx, right? Okay, so now I'm just going to use that rule that the integral of x to the n is x to the n plus 1 over n plus 1, right? That's the rule up above. So now I can drop that integral symbol, okay? Because now I'm finding the antiderivative. Until I find the antiderivative, keep the integral and the dx, the summa and the dx, and then once you've found the antiderivative, you can drop it, okay? So the antiderivative is, I'm going to add 1, so I get 3/2 over 3/2, okay? And then plus a c. Don't forget your plus c. Now, I don't particularly like complex fractions within fractions, okay? So I would prefer that you write 1 over 3/2 is the reciprocal, right? Instead of dividing by a fraction, we're going to multiply by the reciprocal. So this is, 2/3. 2/3. The reciprocal of 3/2 is 2/3. Goodness. 2/3. 2/3. X to the 3/2 plus c. Okay? All right, so I want you to do that for me. When you divide by a fraction, don't just multiply by the reciprocal, okay? Just multiply by the reciprocal. That's much nicer. 2/3 x to the 3/2 plus c. That's my antiderivative. All right, now sometimes we have to rewrite, we need to rewrite this, well, like we did in the last one. We had to rewrite the square root of x as x to the 1/2. So this is the integral of x to the 1 times x to the 1/2, right? dx. And so I need to rewrite this as a single power of x in order to find the antiderivative. Okay, now there is no product rule. There's no product rule, at least that you know of yet, for antiderivatives. There's no product rule. You can't just take the antiderivative of each thing and multiply them together. That does not work. That does not work. Okay. All right, so get that in your head. There's no product rule here. So I have to rewrite this as a single power of x, right? So I'm going to add the exponents, right? I get 1 plus 1/2. That's 2/2 plus 1/2 is 3/2. dx. All right. Now notice I'm writing the integral and the dx because I haven't found the antiderivative yet. All I'm doing right now is just rewriting the integrand so I can apply one of the rules that I know. Right. I'm going to reverse the power rule on this one. All right. So now I think I'm ready. I have it written as a power function, and now I can write the antiderivative as x to the 5 halves, right? Because I have to add 1, add 2 halves to 3 halves. I get 5 halves. And then I'm going to divide by 5 halves. But I don't want to divide by 5 halves. When I divide by a fraction, I'm going to flip it over and make it 2/5. I'm going to multiply by the reciprocal. 2/5. Okay? So, and then I'm going to add the plus c. All right, and there we go. There's the antiderivative of that function x times the square root of x. All right, so let's look at another one here. Again, I need to rewrite this. There's no quotient rule either for antiderivatives. You cannot find the antiderivative of the numerator and the antiderivative of the denominator and then just that's not the antiderivative, okay? So you have to rewrite it as a single power function. And so I have x to the 1/2, I guess I can write it out, x to the 1/2 over x. And when I have the quotient of 2 powers, I can subtract the, oh my gosh. Okay, integral of, okay, let me write it down here. Integral of, okay, so when I subtract those powers, I get x to the minus 1/2 dx. Okay, so now I have it written as a single power function, and then I can apply the rule, the rule for power functions, right? And so now I'm not going to write the integral or the dx anymore, right? Because now I am finding the antiderivative of this. I'm just going to add 1, so I get x to the positive 1/2, right? Because I'm adding 2 halves to negative 1/2, and then I divide by a half. Okay, remember, divide by a half, you want to multiply by the reciprocal. So 1/2 is 1/2. The reciprocal is 2/1. Okay, so that becomes 2 x to the 1/2 plus c. Or if you prefer, you could write it as 2 square root of x, square root of x, square root of, oh my god, 2 square root of x. All right, good grief. Okay, square root of x plus c. All right, one more here. Now this one we can just apply the rule straight away. There's nothing that we had to do to rewrite this one, right? This is our k value, right? We know the derivative of, or excuse me, the antiderivative of sine of kx, right? That's where we were given that in that table on the previous page. And so what do we get? We're going to get, remember, we get a negative, take the antiderivative of sine, you get a negative cosine of 3x, and then we have to divide that. So we're going to get negative 1/3. Negative 1/3 cosine of 3x. And then plus the c, right? Okay. So, I will meet you in the next video.